This is Joseph Brennan recording the EDA 708 displaying data assignment um, due midnight of September 13th, 11:59 p.m. of September 13th. Um, First, the set of data that I'm reviewing is from a pre-assessment given to freshman English classes at Boone County High School at the start of this 2025 school year. It is a pre-assessment assessing students' competency in reading and understanding informational nonfiction. Um, Earlier this week, for the data analysis template assignment, I looked at the data and color coded it. Um, and color coding it as our class text by Fisk says helps make the data make sense. It helps begin to stand out. So I color coded the data, and some things immediately stood out. But upon further inspection, when I plotted the data in charts, some of my assumptions were challenged. I was challenged to be a little more precise with my understanding of what the data said. So we'll look at that. With that being prefaced, in the template, after color coding it, the trends that I noticed were that students who spent more time on the test did better on the test. And that proved to be true when I displayed the data. I'll show you that right now. So I took the students, copy pasted the data, and then sorted it by time spent on the test here. Um, and when I sorted that, it sorted their performance as well. So then I just highlighted these two. Well, I I had to take a time range and then average the time range, and then take all the scores within that time range and average that. Um, and so this was just a way for me to break down the time spent that was conducive to putting this in a legible chart that wasn't all over the place with 52 different data entries. Um, so what I found was this chart right here, that students who spent essentially 26 and a half minutes on the test basically leveled out or did slightly better, but students who spent less than 26 and a half minutes did very significantly worse than students who spent at least that amount of time, which I thought was very interesting. I mean, we could make this a requirement on the test to spend at least 26 and a half minutes before turning it in. But I don't know if that would be a good policy or not. One could test it and then measure the data on that. But um, sometimes policies are counteractive or counterproductive. It could be the case that if we made the requirement that students spend 26 and a half minutes on the test, that these students who would have spent longer on the test might be content to submit their test earlier than they would be ready, and that would lead to a decrease in scores, whereas the students who were so apathetic in the first place not to spend the 26 and a half minutes might just remain that apathetic. And so this well-intentioned policy of take 26 and a half minutes on the test before you turn it in could be counterproductive. Um, it's interesting, but in law, in politics, policy, and administration, sometimes, um, sometimes creating a policy um, can have that kind of counterintuitive effect, can kind of cause the opposite of what you intend. So, but it could be worth a try to try that out. The main takeaway, at any rate, is that we need to identify the students who are turning the tests in too early and intervene in some way to encourage them to spend more time on the test. Let's go back to the template and what I immediately saw by color coding the data. So this second trend that jumped out at me was that the distribution of scores was not random and that there were certain problems on the test that were harder than others on average. So if I look at the data here, I sorted average score by standard, and this was informative to show me what standard students need more work in, and which ones that they're doing well in. And I feel like this is probably a pretty reliable um, look at student performance because the one that they did best on is the easiest standard of all, which is simply comprehension, comprehending what the text explicitly says. And these other ones are more like analyzing word choice, analysis, those kinds of things. Author's purpose. So this shows that this is probably a reliable test in terms of the standards, but the the fact that that some of the problems are harder than others and the distribution was not average or random makes me question some of the validity of the test. Let's look at these two charts here. There were four problems on the test that students, only 20% of students got right. So, and if I add these numbers up here and divide them, I get 17% of the problems on the test. Only 20% of the students are getting right. Let's just round 17 up to 20%, just to draw an easy impression for us to understand. That means 20% of the test is so hard that only 20% of the students are getting that portion of the test correct. 20% of the test is so hard that only 1 out of 5 students are getting those problems right. And I feel like that may indicate that the test itself is too hard. Put in a pie chart, it looks like this. And I would argue that all of this red area just needs to be eliminated. That this is unacceptable for an average of here it says 19% of students to get those problems right. It's unacceptable that 81% of the students are getting these four problems wrong. That probably indicates that those four problems are too difficult, or there may be a problem with the wording on those problems, or those students, our feeder schools within the district are not preparing those students enough in these areas. Now, that gets into a very interesting point, which I was just about to get into, the distribution of scores. Um, Here is the students by number, and their scores. As you can see, no one got above a 71%. This looks like a bell if we put it on its side, and indeed, I displayed the data this way, and it sure looks like a bell, but it's a top-heavy bell. It's way too thin at the bottom, and this number range, this numerical range along the y-axis does not extend to, well, no, this is the students numbered. The the x-axis is determined by the highest score, which was a 71%. If it were extended so that we could see what 100% would look like, we see the bell, it would look like the bell was an inch of the bell was cut off at the bottom. Let me put it this way. The average score on the on the assessment was about a 41%. So if I find 41 right here on the bell, I'm right here. I'm right here on this bottom line of this little layer. And if that's average, if this is truly a bell curve, that should be in the middle of this bell. That should be about right here. So we see this is a top heavy bell. Top heavy in the sense that here's 41. Look at all of these scores before 41. That this test is slanted more towards the difficult end. This test seems to be harder. Now, this pre-assessment came from the HMH into Literature Grade 9 text, and it's their online assessment. So this is a high quality instructional material that is being used by schools throughout the country, um, who are relying on, the validity and expertise, um, of this material. So I have to wonder if the test itself is valid, as we saw earlier with the scores on the standards. It seems to definitely be reliable, but if it is it valid, and I'm not sure. This could certainly we don't see a bell curve. We don't see if we go down here and look at the distribution of scores. Even if we look at 41%, which might be right here, and put like maybe a couple scores over here, we still see that this bar on the left is higher than the bars on the right, and it should be lower if this is going to be a bell curve. It should look like this. So this is definitely slanted towards the harder end. Um, Again, why are we not getting a bell curve if we have a random distribution? I mean, if this is a valid test. Um, I would figure that if this were a valid test, even if the students perform poorly on it, we should still see a bell curve. See a bell curve, within these low number ranges, but still. Um, and what I thought was interesting too is this one person over here who got the 71.5%. They came from a middle school that is not a feeder school within our county. They moved residences and moved into our county, um, and didn't go to one of our traditional feeder schools. So this one data point here could indicate that the reason this bell is top heavy or slanted towards the difficult end is due to a fault within our district schools failing to prepare students, um, in the area of nonfiction. Um, failing to teach certain standards or concepts. So, something to think about, but what I definitely noticed was some problems are definitely harder than others, and the distribution was not random. Um, okay, so let me see here. Oh, okay, I didn't color code it here, but I mean, we can see here item 6 has a 19% of students getting it right. Item 12 has 16% of students getting it right. And then we've got other problems where 54, 56% of the students are getting them correct. So certainly some of these problems seem to be harder than others. You can just see all this red here in this column. Um, and that's what I'm talking about when I say this is an area that students were not well prepared in prior to high school, or the wording of the problem may be the issue. If we see this is standard number 4, and I don't know, are there any other problems with standard 4? There is right here, and 54% of the students got it right. So that would indicate to me that maybe it's not standard 4 that students are having trouble with. Maybe it's the wording of the problem itself. I think that's a sensible conclusion that we can draw from this data. So interesting to think about. Let's go back to the template and look at the final trend that I noticed was that what I noticed when I color coded it, I thought the data was telling me that multiple select problems, as you get 5 choices instead of 4, and then it'll tell you to pick 2 or 3 that are correct. It'll say select all that apply. These, I thought that the multiple select problems had a higher average rate of incorrect responses than multiple choice problems, and that is not correct actually, um, because when I added up the data, I wasn't just satisfied to color code it, because if you color code it, that's what it looks like. If we look at this column, there's not much green in this column right here. Okay. There's not a lot of green in the columns where they have to select multiple problems. But if you actually add the data, students actually receive higher average scores on multiple select problems than the single select or multiple choice problems. What I noticed from the data was that the number of students who get 100% on these problems is vastly different. So the average number of students who get a multiple select problem, who get full credit on a multiple select problem, is much lower than those who answer just the multiple choice single select problems correctly. So this may indicate that these multiple select problems might make it too difficult for a student to receive a perfect score or a very high, a high A or something on the assessment. But the multiple select problems themselves don't seem to be um, adversely affecting student average score, at least not too much. So let's now, if I look at the problem that I presented earlier, with these numbers, these problems that far too many students are getting wrong, like number 3, that's a single select. Number 6 is a single select. Number 12 is a single select. 17 is pretty low. That's a single select. Um, Even over here, number 24, 28% is a single select. So the problems that may be problematic in and of themselves with the wording, they're all single select problems. So if I remove those problems from the average, I'd predict that the average score on these single select problems would be near the average score of the multiple select problems. So this chart here would not be as meaningful. It may be leveled out. And this chart, the thing that did jump out at me when I looked at the data, when I color coded it, would remain meaningful and need to be addressed. So the data tells us there are some problems that need to be removed or changed or considered, investigated, in order to understand better the validity of this test. Um, and then the practice of multiple select problems may need to be reconsidered. Um, After certain changes, these certain improvements are made to the test to make it more valid and reliable. Um, and students need to spend more time on the test to improve their scores. So those are the things that I noticed. Those are the trends that I noticed and what I plotted my data for. One interesting thing that we normally plot data for in our PLCs is we look at score distribution by standard for each teacher, and we see if there are any differences in the trends of scores for standards, which may give us an idea about which teacher is doing a better job teaching those standards in their classroom instruction. So that is the data there, and that concludes my presentation. Yeah, bud.